This is lesson 6.2, factor trinomials. The learning objectives are to factor trinomials of the form x squared plus bx plus c, factor trinomials of the form ax squared plus bx plus c using trial and error, factor trinomials of the form ax squared plus bx plus c using the AC method, and factor using substitution. All right, so let's get started with our first objective, to factor trinomials of the form x squared plus bx plus c. Now, these are trinomials because they have three terms, right? A polynomial with three terms is called a trinomial. And also, one detail is we're mainly going to be looking at quadratics. Quadratics is when the highest power of the variable x is 2, right? So we've got a quadratic term, an x squared term, a linear term, that's x to the first, and then a constant term. All right. So how do you factor trinomials of the form x squared plus bx plus c? Well, you can follow this four-step process that I've created for you. Step 1, write the factors as two binomials with the first terms x. Step 2, find two numbers m and n that multiply to make c. So m times n equals c, but they also add to make b. M plus n equals b. Step 3, use m and n as the last terms of the factors. And step 4, check by multiplying the factors. So here I have examples 6.9 through 6.13 listed, and we'll go through them one at a time all the way until we get to the bottom. Okay, so let's zoom in and focus on this four-step process for the first trinomial. I see x squared plus 11x plus 24. Now, the first thing I do is write parentheses, so two sets of parentheses for binomials, and I put x at the beginning of each binomial. All right, so this is the setup. These are parentheses for two binomials. We put x at the beginning because x times x is x squared. So this is the setup. Now, the next thing to do is list all of the factors of the constant. Okay, so this is the constant. It doesn't have an x with it. And we need to list all of the possible factors. Okay, so let's start. 24 is 1 times 24, and it's also 2 times 12, and it's also 3 times 8, and it's also 4 times 6. Okay, these are all of the possible factors that multiply together to make 24. So we list them. And I like to do it in a specific order. I start with 1 and the number itself. Then I increase to 2 and I see, is there a number that multiplies with 2 to make 24? And yes, that's 12. Then I move on to 3 and I think, is there a number that multiplies with 3 to make 24? Yes, that's 8. And then I move on to 4 and I say, is there a number that multiplies with 4 to make 24? And yes, that's 6. And you'll see the factors get closer and closer together. 1 and 24, 2 and 12, 3 and 8, 4 and 6 now. 4 and 6 are only 2 apart from each other. If I try to keep going like 5, well, 5 is not, one of the pieces of 24. 24 is not a multiple of 5, so 5 wouldn't work. And then, I'd move on to 6, but I've already used 6. 6 is right there. So once I get to the closest factors that I can together, I know I'm done. Great. So now that I've listed all of the factors, we are looking for one of these four sets of factors to make the m and the n. So these are, m and n values that multiply together to make the constant, which in this case is 24. But they have to add together, right, to make the b value. Okay, so the b value is the linear coefficient, right? B. In this case, the b value of the linear coefficient is 11. So I look at these and I say, do any of them add together to make 11? And 1 and 24 doesn't. So maybe I get out my canceling pen and I say, nope, that's not going to work. And 2 and 12, they can't sum to make 11. But 3 and 8 can. 3 plus 8 is 11. Okay, so I have found the set of factors that will work. And just for fun, we'll say, well, what about 4 and 6? Can they sum to make 11? No, 4 and 6 sum to make 10. And so I have found these values m and n, right, that we referred to in our step process, and they multiply, right? 3 times 8 multiplies to make 24, and 3 plus 8 sums to make 11. So that's why we are going to put a positive 3 right here and a positive 8 right here. Now it doesn't matter in this case where I put it. I could have put 8 here and 3 here, right? It doesn't matter where I put these in this case because um, they're just the terms that go with x. And so there we go. Now you can always check to see if you have factored correctly. And to check to see that you have factored correctly, then we look at step 4. We multiply the factors back together. Okay, so if I multiply this binomial times this binomial, I can do it, like you've learned, by foiling, right? What if I foil these binomials? What would I end up with? And so I say, well, the first terms multiplied together are x times x. That gives me x squared. And then the outer terms multiplied together would be a positive 8x. And the inner terms multiplied together would be a positive 3x. And the last terms multiplied together are 3 and 8, so they make 24. And then we combine any like terms, and we, see that these outer and inner terms can be combined because they're like terms. And look at this. When we multiply it all back together, it gets x squared plus 11x plus 24, which is exactly what we started with. So you could always check to make sure you have done it correctly by multiplying it back out to see if it results in the same thing you started with. Okay, so there you go. That is how we use a 4-step process to factor trinomials. And so I went kind of slowly and I showed you every little detail for this case. I'm going to speed things up as I continue through some of these next examples, but please follow along. Now, I'm going to go ahead and set up for this next one by putting 2 sets of parentheses and putting the variable y at the beginning of each set. The variable y is what we're dealing with instead of x, like in the last example. Okay, and now I find all of the factors that multiply together to make 28. I'll do it in a list. I have 1 times 28, 2 times 14, 3 doesn't work, and 4 times 7. And these are all of the possible factors of 28. Now, I look at them and I say, well, which set can sum to make negative 11 the b value? And I think for a second, wait, it's going to be negative 11. So my factors have to be negative. I have to have negative factors. Okay, so I think for a second, well, if I made 4 and 7 both negative, then they would sum to make the b value of negative 11. And negative 4 times negative 7 multiplies to make positive 28 because a negative times a negative is a positive. Okay, so there was no way for me to use the 1 and 28 or the 2 and 14 to get what I wanted. So you'll see only one set of factors ever works for factoring a trinomial like this. And so to finish, I will put a minus 4 in one of the sets of parentheses and a minus 7 in the other. And once again, it doesn't matter. I could have put the minus 7 here and the minus 4 here, and I would have been correct because multiplication is commutative of these two binomials. Multiplication, it doesn't matter the order with which you do it. Great. So now let's go ahead and move on to this next one. Okay. And one thing that I notice as I look at this trinomial is its terms are out of order. Usually we put the quadratic term first, the linear term second, and the constant third. And so if things are out of order, go ahead and reorder them. That's my recommendation to you. So I'm going to put that positive x squared first, and then the positive 2x second, and then the negative 48 third. And now it's in order from, the quadratic term to the linear term to the constant term. Great. So whenever you see things out of order, you can go ahead and take the opportunity to put them in order. Now we're going to set up for the factoring of this trinomial. So we'll create two binomials and we'll put x at the beginning of each one. Because, of course, x times x, those first terms multiplied together would give us that x squared. Now, let's list all of the factors of 48. And so we start and we say, well, 48 is 1 times 48, but it's also 2 times 24, but it's also 3 times 16, but it's also 4 times 12, but it's also 6 times 8. Okay, so 48, this number, this constant, has a lot of factors, a lot of possible factors for this scenario. Okay, but we need the set of factors that will sum to make positive 2, okay, and it will also multiply to make negative 48. Because that's negative, I know that one of my sets of factors is going to be negative. Okay, one of my factors of the 2 will be negative. So I'm going to just dig in here and see which of these sets of factors can sum together to make 2. Okay, so I notice that 6 and 8 have a difference of 2 between them. 6 is 2 away from 8. And that could be really helpful because I see this has to be positive 2 when I sum them together. So I'm going to take 6 and make it negative. I take the smaller value to make it negative because I notice this is positive 2. So negative 6 plus 8 gives me positive 2. That's exactly what I want, meaning none of these sets of factors above would have worked. Okay, so this is a little bit about trial and error for you. You have to go through a trial and error process to find the correct set of factors. And so now I can put the negative 6 in one of the binomials and the positive 8 in the other binomial. And it doesn't matter, once again, which I put them in these cases. All right, so there we go. We have factored. Now, of course, we could take this result, and if we multiply it back together by foiling, we should get what we started with, right? So x times x is x squared. X times 8 is 8x, and then 8x minus 6x, right, because I'm going to multiply the inner terms together, is 2x. Okay, that results in 2x. Negative 6 times positive 8 is negative 48. We have done it correctly. Let's move forward into this next example. And this next example, I see, instead of only one variable, I see two variables. There's r and there's s, right? In the past, we've only had one variable, x or y, right? Here, just the variable x. Now we have two variables. So let's hop in and see how we can pull this one off. So I'm first going to create two binomials, like this. And I know that r times r is r squared. So I'm going to make r the beginning of each binomial. All right, and now I really have to think about this next part in the sense that I've got this second variable s, okay? And so I need to find some values that multiply to make negative 9s, but sum to make negative 8rs. Well, let's go ahead and just focus, ignore the variable s for a second, and just focus on the numerical values. Imagine if this negative 9 was a constant. So let's find all the factors of 9. I have 1 times 9, and I have 3 times 3. These are all of the factors of 9. And then I ask, does one of these sets of factors sum together to make negative 8? Can I sum any one of these? Can 1 and 9 make negative 8? Can 3 and 3 make negative 8? Well, I figure out, well, 3 and 3 could never make negative 8 because 3 and 3 sum to make 6 total, and 3 minus 3 is 0. Okay, so then I think, well, what if I make this 9 negative right here? And 1 minus 9 is negative 8, and 1 times negative 9 is negative 9, so I have found the correct factors to use. And so I put a positive 1 in one of the places and a negative 9 in the other place. And then because this had s squared right here as the last term with the constant, I'm going to put an s here and an s here. Okay, so s goes there, s goes there. And lastly, 1s, like 1 times s right here, well, 1s is just s. So you could rewrite that and simplify it so it just looks like r plus s. Okay, so we have done it. We have factored this trinomial that had 2 variables in it. Of course, you could multiply them together by foiling to make sure that that's correct. Okay, it is. Now let's look at this last example here. And we have u squared minus 9uv minus 12v squared. And once again, we see 2 different variables, u and v, right? U and v on the other end. So let's go ahead and just start by doing what we always do. We set up our parentheses and we put the variable u at the start of each one because u times u will give us this first term u squared. And now I'm going to ignore the v's for a second, and I'm just going to think about this negative 12 and negative 9, this constant and linear term. So let's find all of the factors of 12. I have 1 times 12, 2 times 6, and 3 times 4. It seems like these are all of the factors that multiply together to make 12. But it's negative 12, so I know that one of my sets of factors has to be negative. Okay? And I know they have to sum to negative 9. And I think for a second, are there any values that sum to negative 9 in this case? 1 times 12 doesn't, 2 times 6 only makes 8, and 3 times 4 doesn't work. Okay? So I'm thinking, and man, I don't know which things will make that happen. Okay? And so at this point, I may be stuck, right? So sometimes certain trinomials are not factorable, okay? So we are always looking to see if something's factorable or not. The previous 4 were factorable, but this one, nothing is working. Nothing, this doesn't work, this doesn't work, this doesn't work to make negative 9. None of them will do it. So we stop right there and we say, well, this is not factorable. This is the answer. This is not factorable. Okay? So this is important for us to address this because not all trinomials can be factored. Okay? And we have to recognize when they can't be. So yes, this one could be, this one could be, this one could be, this one could be. We got to this, we tried to do it, and it just didn't work. It's not factorable. Awesome. Well, I want to go over something very specific about the signs of these trinomials. So you'll see in the examples that we did, we had a plus-plus situation where we had plus signs both between the terms. Now there's a minus plus situation, and now there's a plus minus situation and a minus minus situation. So all 4 of these were technically kind of distinct and different factorings of trinomials because you had plus plus, minus plus, plus minus, and minus minus situations. So right here, I have a strategy for factoring these trinomials where you focus on the signs, okay? So when C is positive, the constant, M and N have the same sign, all right? So that's an important feature. So when you see like these examples up here, we had plus and plus for the constant. The constant was positive, and so the factors had the same signs, either positive, positive for the 3 and 8, or negative and negative for the 4 and 7. Okay? So that's an important thing to see. Now, when the constant is negative, M and N have opposite signs. So here I see the constant is negative, and so M and N, they will have opposite signs, negative 6 and positive 8. Okay? And here I saw a negative sign for the constant, And so I see that when I factor, I have opposite signs. Okay, so this little piece right here can help you see all four cases, right? When I have a plus plus, what happens? I have positive in both cases. When I have a minus plus in the trinomial, my factor pieces are going to both be negative. When I have a plus minus, I will have a plus minus here in the answer. Also, if this is positive, that means the bigger factor is positive and the smaller factor is negative. Now, when I have a minus minus like this, that means the bigger factor is negative and the smaller factor is positive. Okay, so go ahead and analyze this and make sure you're comfortable with it. Of course, you could try these examples on the right-hand side, which are comparable to the ones that we've just gone through. We're ready to move forward, and now we are going to practice factoring trinomials of the form ax squared plus bx plus c using trial and error. Okay, so what's different about this one? Well, this has an a value. In front of the x squared, the coefficient is greater than 1. Okay, so everything we've dealt with up to now, looking back, the quadratic term had a coefficient that was 1. 1x squared, 1y squared, 1x squared, 1r squared. So how do we factor trinomials when we have an a value greater than 1? So here's the step process that we're going to follow. Step 1, write the trinomial in descending order of degrees as needed. Step 2, factor any GCF. Step 3, find all the factor pairs of the first term. Step 4, find all the factor pairs of the third term. Step 5, test all possible combinations of the factors until the correct product is found. And step 6, check by multiplying it back together. All right, so here I have this trinomial, and we're going to follow this nice step process here. And we're starting with 4x cubed plus 16x squared minus 20x. Now, make sure that the terms are written in descending order of degrees. So we look at the exponents. They're the degrees, 3, 2, and x to the first, 1. They're written in descending order of degrees. Next, step 2, factor any greatest common factor. So you'll look back to our last lesson in which we discussed greatest common factors. Now, those are the factors that all three of the terms share in common, and we factor it out. So when I see 4, 16, and 20, my brain says, well, the GCF of 4, 16, and 20 is 4. That is the greatest common factor, because 16 and 20 are both multiples of 4. And now the GCF of x cubed, x squared, and x is x. Now, this is what I'm factoring out of all three terms. And then what's left is x squared plus 4x minus 5. Okay? So if I take 4x cubed, I divide out 4x, I'm left with x squared. 16x squared divided by 4x is 4x. Negative 20x divided by 4x is negative 5. Now this, in parentheses, is a trinomial that we can factor like we did previously, because it's a 1x squared trinomial. And so I'm going to factor it. And so I create two sets of parentheses, and I put x at the beginning of each binomial. And then I find the factors of 5. The constant is 5, so I'm going to find all the factors of 5. And I realize, wait, 1 times 5, that's the only set of factors because 5 is a prime number. And how can I turn 1 and 5, sum them together to make 4? Well, I would have to make the 1 negative, which makes sense because negative 1 times 5 is negative 5, and negative 1 plus 5 is 4. That's exactly what I want. So we write those in the parentheses with x, the negative 1 and the positive 5. We're done. We have factored this trinomial completely. Okay, let's try another. What if we end up with a trinomial that is 3y squared plus 22y plus 7? Well, first, we make sure everything's in descending order of powers. 2, 1, 0 y's. Yeah, there are 2 y's, 1 y, 0 y's. So yeah, everything is in descending order of degrees. Great. Moving on, factor any GCF if you can. And so we ask, are there any GCFs for these three terms? Is there a GCF? And the answer is no, there's not, because 22 and 7 are not multiples of 3, and so there's no common factor in this case. Great. Let's move on to step 3. Find all the factor pairs of the first term. Okay, so the first term is a coefficient of 3. Let's find all of the factors of 3. Well, that's 1 times 3 because 3 is prime. Now, step 4, find all the factors of the third term. Well, the third term is 7, right? That's the constant term. Well, 7's factors are 1 and 7. And that's the only set of factors because 7 is prime. In fact, we get really happy when we see prime numbers because they only have one set of factors, and that makes our life very easy. Okay, so now I'm going to write the parentheses of the two binomials that I'm factoring. And in the parentheses, yes, I'm going to put y and y, but I'm not just going to put y and y. I'm going to put 1y and 3y because those are the factors that go with y squared. Okay, 1y and 3y. So some people like to put the larger one first, so I'll do that, 3y, and then I'll put the 1y here. Great. And now we are going to put the constants factors in these two spots. But we have to be very careful because we need the outer and inner terms to multiply and sum together to make this middle value, 22y. Okay? So to do that, I've got to do a little trial and error. We have to test all the possible combinations of the factors until the correct product is found. Okay? So I think for a second and I say, well, if I did 3 times 7, that's 21. And if I added that with 1 times 1, 1 times 1 is 1, and 21 plus 1 is 22. So that's what will make it work. Okay, so I need to put the plus 7 here so that 3y multiplies with 7 as the outer terms of foiling. Okay, so that would give me a 21y when I multiply them together. And then I have to put the positive 1 right here because when I multiply the inner terms of foiling together, that would make a 1y. And 1y plus 21y equals 22y, which is exactly what I want. Here's my 22y. Okay, so when you place the pieces of these two binomials together, you have got to think of multiplying the outer terms and the inner terms together to make this b value. Okay, this is probably one of the more thoughtful things you'll have to do as you're learning how to factor. So I'm going to leave that right there. And of course, if you needed to, you could do step 6 for yourself. Check by multiplying. If we multiply by foiling 3y times y, 3y times 7, 1y times y, and 1 times 7, it would give us 3y squared plus 22y plus 7. Great. So you could always check by foiling. Let's go ahead and address another problem. This is 6b squared minus 13b plus 5. And I notice that the b's are in descending order of degrees, right? B squared, b to the first, no b's, b to the 0. All right, so they're in descending order. And now I look for any GCF. All right, so I look for, the coefficients 6, 13, and 5. Well, they don't have a GCF, right, other than 1. And then the B's, well, this doesn't have a B, so there's no GCF for the B's. And so there's no GCF that I can factor out. And so I proceed by finding all of the factor pairs of the first term and then all of the factor pairs of the third term. So I'll do that really fast for you guys. So I look at the first term and its coefficient is 6. So I write 1 times 6 and 2 times 3. These are all of the factors of 6. Now I look at the last term, the constant, and it's 5. And so I write all of the factors of 5, realizing it's a prime number, so its only set of factors is 1 times 5. Next, I'm going to set up my parentheses, okay, because I'm factoring this trinomial into two binomials that would be multiplied together. And I put b, not just b at the beginning, okay, but there will be these b's, but I have also the possible coefficients of 1 and 6 and 2 and 3. So I could have a 1b and a 6b based on this set of factors, or a 2b and a 3b based on this set of factors. And this is where we have to test a little bit. So if we multiply one of these sets of factors with this set of factors, we need to make it negative 13. And since I see a minus plus situation, I know that both of these factors here are going to be negative. All right? So negative 1 times negative 5 will be positive 5. But this negative 1 and negative 5 will work with one of these sets of factors to make negative 13. And I think about it for a second, and I say, well, I think I've got it. So if I took the 2 and the 3 and worked with them with the negative 1 and negative 5, that could get me my negative 13 that I want. Let me show you how that works. So I'm going to take my 2 and my 3 and put them as the coefficients that go with b, okay? And, like I said, sometimes students prefer and professors prefer to put the larger value first. But it really doesn't matter. I could have put 2b here and 3b here. It would have been the same idea. But what is very important is that we make sure that these get placed correctly here and here, okay? Because we need the outer and inner terms of foiling to sum together to make negative 13b. So looking at this, I would put the negative 5 right here. Okay. So negative 5 I'm placing here because if I multiply the inner terms together, that's 2b times negative 5, which is a negative 10b. Okay, so I've got negative 10b so far. And then that negative 1, that's right here, this negative 1, I'm going to place it right here. So there it is. Because when I multiply 3b times negative 1 as the outer terms of foiling, I get a negative 3b. And then I sum up those pieces. I add them together. And negative 10b plus negative 3b equals negative 13b, which is, like we said, the middle term that we wanted. Okay? There we go. So it takes a little bit of trial and error. You have to say, okay, well, am I going to be dealing with the 1 and the 6 multiplied with the negative 1 and negative 5, or the 2 and the 3 multiplied with negative 1 and negative 5? And so you'll test and you'll place things in certain places, and you'll check the outer and inner terms of foiling, multiplying those pieces and summing them together and seeing if they make the middle value. Okay, so this is trial and error. Great, we've done it. Let's move forward and let's look at this next trinomial to factor. This next trinomial is negative 10y to the fourth minus 55y cubed minus 60y squared. And I look, are the degrees in descending order, right? Y to the fourth, y cubed, y squared. Yes, they're in descending order from 4 to 3 to 2. Great. Next, I ask myself, is there a GCF? And I look at the values, -10, -55, and -60, and I notice that they are all multiples of -5, or, of 5 in the first place. But I'm also going to pull out a negative. So -5 is the GCF. But what about the GCF of the variables? So I have y to the fourth, y cubed, and y squared. Well, all of them have at least a y squared, right? So I pull out a y squared as well when I factor. Now, I'm going to have a trinomial left over, right? I just factored out the GCF out of all three of these terms. And so what do those terms become in the trinomial? Well, you could think of dividing. -10 divided by -5, that's +2. And y to the fourth divided by y squared is y squared. Moving on, we have -55 divided by -5, which is +11. And y cubed divided by y squared, which is just y. And lastly, we have a -60 divided by -5, which is a +12, and a y squared divided by y squared, which is no more y's. Great. So we have just factored out the GCF and figured out what was left inside. Now, this stuff left inside, that is a trinomial that we could possibly factor. Let's see if we can factor it. Now, it has an a value that's greater than 1. Its a value is 2. So I'm going to list all of the factors of the a value. So I'm going to put them in red here, 1 times 2. And then all the factors of the constant of 12, right? So setting this up, giving myself a little space. 1 times 12, 2 times 6, 3 times 4. These are all the factors of 12. Now, I'm going to need to take this set of factors and combine them with one of these sets of factors with the outer and inner terms of foiling to make this middle value 11y, right? To make 11. So how can I take this and one of these to make 11? That's what we have to figure out. And so we're going to set up for success. First, let's write the GCF that we factored out. Then we're going to create two binomials. And since there's only one set of factors here, I know that this is going to be a 1y and a 2y, right? So I'm going to be putting a 1y and a 2y here and here. And I'll put the larger value first and the smaller value second. But it wouldn't matter if you decided to put the larger one and the smaller one swapped. So you could put y and 2y. It doesn't matter. But what does matter is now what we put here and here. And so we have to play with it for a second. And I notice this is a plus-plus situation, which is awesome because then I don't have to worry about any negative factors. No negative factors. In fact, because of this plus-plus, I could just write two plus signs and I don't have to worry about it, okay? Now, I could take 1 and 2 and multiply them, let's see, could I do it with 2 and 6 or 3 and 4 to make 11? How would I do that? What if I did 2 times 4 and 1 times 3? That's what I'm thinking. I need 2 times 4 to make 8 and 1 times 3 to make 3, and 8 plus 3 will give me 11. So that's what my brain is thinking, okay? So I'm going to take this and this, okay? And so now I need to think about the outer and inner terms of foiling. So if I took 2y, I'd need to multiply that with 4, right? 2y times 4 would give me 8y. And then this y right here, I'm going to multiply that 1y with 3. And it goes right there. And 3 times y is 3y. And 3y plus 8y is 11y, which is exactly what I wanted. I wanted 11y. Great, we've done it. We have factored that trinomial. So the answer is this stuff right here. This is the factoring of what we started with. Great. Now, of course, you could take all of this and multiply it back together and check to see if it gives you the starting stuff. Now let's look at this last example of this section, which is 18x squared minus 37xy plus 15y squared. All right? So my brain immediately goes to this step process that we've been using this whole time and thinking through that step process. But one detail about this exact trinomial that we're looking at is it doesn't just have one variable, x, it also has the variable y in it. Now, for the purposes of starting, like we did before, you could ignore the y stuff and just think of it like we see without the y's there. And then we could include the y's at the very end. So I'll think to do it like that. Now, I look at these coefficients, 18, negative 37, and 15, and I say, do they have a GCF? And I think for a second, and the answer is no, they don't, because 37 is not a multiple of anything, I think. I think it's a prime number, right? So I'm thinking that this thing's a prime number that I'm dealing with. Okay, so how am I going to handle this? Well, I'm going to find all of the factors of 18 and then all of the factors of 15 and put them in a little list on the side. So all the factors of 18 are 1 times 18 and 2 times 9 and 3 times 6, and that's it. Okay, so I found all the factors of 18. Now all the factors of 15 are 1 times 15 and 3 times 5. Okay, now that I have found all of these factors, I'm going to create sets of parentheses, and I'm going to start a little trial and error. I'm going to play with things. And looking through this, I think for a second, and let's look at the minus plus situation. So this is a minus and this is a plus, which means that both of the factors are going to be negative, right? So I'm dealing with negative factors on this side. Great. So just placing those negative factors. Now I'm going to choose one of these sets of factors and mix them with one of these sets of factors. And if I think about it for a while using trial and error, I come to the conclusion that I could take 2 and 9 and combine them with negative 3 and negative 5 to make negative 37. And so you'll see me do that here. Now I'm going to take that 9 and 2 and place them with the variable x, right? They're the coefficients of x, 9x and 2x. They go there and there. And now I would need to check the outer and inner terms of FOILing to see if I can make negative 37. So if I multiply 9 with negative 5, that would give me negative 45. And then 2 times negative 3 would give me negative 6. Well, that won't quite work. So I keep thinking for a second. What if I did 9 times negative 3, which is negative 27, and 2 times negative 5, which is negative 10? That would give me negative 37. So that will do the trick. You'll watch me do it. So 9 gets multiplied with negative 3 as outer terms, and those outer terms multiply together to make negative 27x. And then we also have 2x, this 2 being multiplied with this negative 5 as inner terms, right? So they're the inner terms there and there. And 2 and negative 10x Well, that all makes negative, oh, forgive me, I got ahead of myself. This is negative 5. There we go. And that's what makes negative 10x. Great. And negative 10x minus 27x is a negative 37x, which is exactly what I wanted. Great, it works. Now, there's one last detail that I said, let's cross them out. The y's, you see these y's? Well, we cross them out. Let's make them visible again. Okay, so I'm going to just make those y's become visible. And the funny thing is it makes it seem really complicated, but all I have to do is multiply a y onto both of these terms, because y times y will give me y squared here at the end. Okay, so we have done the factoring. We are done with this factoring, and hopefully I have helped you make sense of this complex factoring problem. Great, we're going to move forward into our final few examples for the day. Now, there's another method that can be used other than this trial and error method that we used here above, right? So I just taught you how to think to factor trinomials with the trial and error method, but there's also a method called the AC method. Okay, so you're going to, by the end of this lesson, decide which one you like best. And then you'll use it. You can use whichever method you feel you enjoy the most. So how to factor trinomials of the form ax squared plus bx plus c using the AC method. Step 1, factor any GCF. Step 2, find the product a times c. Step 3, find two numbers m and n that multiply to a times c, right? So m times n equals a times c, and they add to make b. So m plus n makes b. Then split the middle term using m and n, and then step 5, factor by grouping. Now, you learned how to factor by grouping in your last lesson, in lesson 6.1. Then once you've factored, you can check by multiplying all the factors back together. All right, so let's try this AC method and see what we think. So first I look at the trinomial. I notice it's in descending powers of the variable x. And I also notice that there is no GCF. There's no greatest common factor of 6x squared, 7x, and 2. So I'm moving straight on to this step 3. All right, so we're going to find numbers m and n that multiply to make a times c. So what is a times c? Well, it's 6 times 2. A is 6, c is 2. So we're going to multiply them together. We're going to say 6 times 2 equals 12. Now we need to find the factors of 12. What are the factors of 12? Well, we've got 1 times 12, and 2 times 6, and 3 times 4. Those are the factors of a times c. Great. Next, well, we are going to split this 7x, right, this b term, into two separate terms. The 7x, we're going to split it, okay? And so we can write this as 6x squared plus, well, I look at these sets of factors, and I'm going to try the 3 and the 4. So I write a plus, I'll put the 4 first, and then a plus 3x, and then a plus 2, like that. So what I've done is I've split this b term, this middle term, into two separated terms from my list of options here. Okay? Great. Why did I choose 3 and 4 instead of 1 and 12 and 2 and 6? Because 3 and 4 sum to make this 7 right here. 1 and 12 doesn't do it, right? So I didn't choose 1 and 12. And 2 and 6 can't add to make 7, so I didn't choose that one either. So that's why I chose what I chose. Now that I've split this 7x into two pieces, I can factor by grouping. So factoring by grouping is taking the first two terms and factoring out the GCF out of those, and then the second set of two terms and factoring what I can out of those. Okay, that's how it starts. So what is the GCF of 6 and 4? Well, it's 2. And the GCF of x squared and x is x. So the GCF of the first two terms is 2x. And in parentheses, I'm left with 3x plus 2. And then I have a plus, and then this 3x plus 2, there's no GCF. Well, I shouldn't say there's no GCF. The only thing that I can pull out of it is a 1. Okay, there's a 1 that I can factor out. Because when you factor a 1 out of something, it stays the same. Great. Now that we have pulled out the GCFs of 2x out of the first two terms and 1 out of the second set of two terms, I can group these GCFs together, the 2x and the plus 1, into their own binomial. So I have 2x plus 1, and it's grouped into its own binomial that's multiplied with the matching binomial. You'll notice that these two binomials were matching here and here. They're the same thing. So we write that second binomial multiplied with the GCFs that we factored out. And this is the answer. This is the full factoring. And you would ask, how is this the same thing as this? Well, when we FOIL, we multiply the first term with the first term and last term, right? So we get the first and the outer. So here's the first and the outer. And then we multiply the inner and the last terms together. So this is the same thing that we do when we FOIL. So we can rewrite this as this. Let's try this process again. So I have another example to help us to practice this skill. So when I see this trinomial, 10y squared minus 55y plus 70, I notice, yeah, the variables in descending powers of, 2, 1, and 0. Okay, we're good to go there. Now, is there a GCF? Well, 10, 55, and 70 are all multiples of 5. So yes, I could factor out a 5. 5 is the GCF, and I'm left with 2y squared minus 11y plus 14. Okay, now this, let's see if this can be factored. Okay, and why don't we try using the AC method to factor this stuff? All right, so the AC method says multiply together these factors of 2 and 14. The A value is 2, the C value is 14, 2 times 14 is 28. Then find all of the factors of 28. So I've got 1 and 28, 2 and 14, 3 doesn't work, 4 times 7, and these are all of the factors of 28. And now I think for a second about which one will sum to make negative 11. Okay, I need one of these sets of factors to sum to make negative 11. Well, if I make 4 and 7 both negative, negative 4 plus negative 7 is negative 11. I have found them. This is the set of factors I'm going to use. And the 1 and 28 doesn't work, and the 2 and 14 doesn't work. Okay, so I have found the only one that works. Great. And so now I split this negative 11y into two pieces. And I rewrite this whole expression as 5 times 2y squared minus 4y minus 7y plus 14. Okay, so I just split this negative 11y into two pieces, negative 4y and negative 7y. Cool. Now that I've done that, I can take this stuff and factor by grouping. So I take the first two terms and I take the second set of two terms. And I'm going to see what I can factor out of those. And so I have 5 times, well, these two terms, their GCF is 2 and y, 2y, right? So looking at those, I factor out a 2y, and I'm left with a y minus 2. And then this set of two terms, I could factor out a negative 7. I'm going to factor out negative 7, and I'm left with a y minus 2. Okay, so these two terms, their GCF was 2y. These two terms, their GCF was negative 7. And I notice in parentheses, I now have a y minus 2 and a y minus 2. So factoring by grouping will work. And so to finish, I write the final result, 5 times 2y minus 7 times y minus 2. Explaining this, I take the GCFs of 2y and negative 7 and I put them in their own binomial. And then I take the y minus 2 matching binomial and I write it here. This is the same process as FOILing. First, outer, inner, last. First, outer, inner, last. Okay, so it's the same thing. And we have factored completely. We're done. The last objective of today is to factor using substitution. We want to factor using something called substitution. So we're going to look at these examples, 6.21 and 6.22 pretty quickly here. I see x to the fourth minus 4x squared minus 5. Okay, and I notice that, man, I've got higher powers than just a quadratic, right? Quadratic is a power of 2 for the highest term, but this one's double that. That's 4. And this is typically a linear term, x to the first, but now it's double that. It's x squared. And so one trick to use is called substitution, where I could say that something like u is the same thing as x squared. Okay, so whenever I have an x squared, I could substitute a u in for it. And u is the common variable used for substitutions in mathematics. Okay, so when I see x to the fourth minus 4x squared minus 5, and I substitute u in, then I could rewrite this as, well, x to the fourth is u squared. And that's minus 4 times, well, x squared is u, minus 5. Great. So what I've just done is I've replaced any x squared with u. X to the fourth is x squared times x squared. So that's u times u, which is u squared. All right? Now that I have substituted in, I can now factor this substitution that I created because this is an easy trinomial that I can factor. So I'm going to factor the trinomial using the skills I have. So I write u and u in those first spots, and then I find the factors of 5, the constant, which is 1 times 5. But I also notice this is a minus minus situation, meaning I'm going to have negatives on both of my factors. Okay? And so actually only on one of my factors, forgive me, I'm going to have a negative on the 5 because in the minus minus situation, the larger factor is negative. Now I put a positive 1 and a negative 5 here and here, and I have factored this, this trinomial into this. At this point, I'm simply going to go back and say, well, what was my substitution? What did u represent? It represented x squared. And so these u's that I have, I'm going to turn them back into x squareds. And I write the final answer as x squared plus 1 times x squared minus 5. Okay, so this is a process called substitution, in which we see something that looks like it's set up kind of like a quadratic, but it's not quite. It's got higher powers. And so what I do is I say x squared equals u, right? And then I substitute in that u for x squared. I factor that. And then once I've done the factoring, then I replace all of these u's with what they originally were, x squareds. And I have now factored completely. Let's try this process one more time right here in this example. This says x minus 2 squared plus 7 times x minus 2 plus 12. Well, this looks like a quadratic, but instead of just x, we have x minus 2. So what I could do is say that there's this u that equals x minus 2. So I'm going to say x minus 2 equals u. And so I'll turn these x minus 2's into u's, and I'll have u squared plus 7u plus 12. And I will now factor this once the substitution is in. And so when I factor this trinomial, I get two binomials that have u in the front of each one. Well, what goes here? I have to find the factors of 12. 1 times 12, 2 times 6, 3 times 4. And which set of factors will make 7? Well, 1 and 12 can't sum to make 7. And 2 and 6 can't sum to make 7. But 3 and 4 can. So 3 and 4 are my options. So I put a positive 3 and a positive 4 here and here. And then I have completed the factoring. But I have to go back and say, well, what was u? U is x minus 2. That's what u is, x minus 2. So I'm going to change the u's into x minus 2's. And then I notice, well, I've got the x minus 2, but it was plus 3. And then I have the x minus 2, but it was plus 4. And so I can simplify this a little further because negative 2 plus 3 is 1. So in this binomial, I get x plus 1. And then negative 2 plus 4 is positive 2. So in this binomial, I get x plus 2. And I have now completed my factoring all the way. So when I have this, it seems really complicated, but if I use u substitution, it simplifies so that I can factor easily. Then I get rid of the substitution that I did, replacing back what I originally had, and now I can finish the factoring. Okay, so there you go. We have just talked about factoring trinomials, and we talked about a lot of different scenarios that you would come across as you factor those trinomials. Thank you, and have a wonderful day.